my dear students. Welcome to my channel Physics by MK. In my previous video, I explained you about the methods of vector addition, and there are three types of addition. One is geometric method, in which we used triangle of addition and polygon of addition. And the second method, which is numerical method, we used parallelogram of addition. And now I am going to explain the third method, which is component-wise addition method. So let us consider a vector A bar represented in space with reference to a coordinate system. Now, this vector A bar is also called position vector of a particular point, and it is represented numerically as A bar is equal to AXI plus AYJ plus AZK. Now, AX, AY and AZ are the components along x-axis, y-axis and z-axis. And say for example, let the magnitudes 2i plus 3j plus k. Similarly, if there is another vector b bar, which is bxi, byj and bzk, and in the numerical form I cap minus 2j cap minus 2k cap. So if you are asked to find the resultant of A bar and B bar, that will be A bar plus B bar is equal to, in this method, we have to add the common components. X component of A, Ax, and X component of B, Bx into I cap. Similarly, Y component of A and Y component of B, that is Ay plus By multiplied with G cap, and the third component Az plus Bz multiplied with K cap. This is along Z axis. And in numerical way, it is 2, Ax is 2 in A bar and Bx is 1 in B bar. So it is 2 plus 1 into I cap. Here, Ay is 3 and By is minus 2. That's why it is 3 plus minus 2 into J cap. And here, it is 1 plus minus 2, that is minus 1. That's why the vector A bar plus B bar is equal to 3i plus j minus k. So for any vector, we have to find the magnitude and direction. For that, the modulus of A bar plus B bar is under root 3 square plus 1 square plus minus 1 whole square. That means you are squaring Ax plus Bx whole square plus Ay plus By whole square plus Az plus Bz whole square under root. And numerical way, it is 3 square plus 1 square plus minus 1 square, which is 9 plus 1 plus 1, which is under root 11. Now, the direction of A bar plus B bar is given by three angles in terms of their cosines. So, alpha with x-axis, beta with y-axis, and gamma with the z-axis. And cos alpha is ax plus bx by modulus of A bar plus B bar, and which is 3 by root 11. Cos beta is ay plus by by modulus of A bar plus B bar, which is 1 by root 11. And cos gamma is az plus bz by modulus of A bar plus B bar, which is minus of 1 by root 11. And you can represent alpha as cos inverse 3 by root 11, beta cos inverse 1 by root 11, and gamma cos inverse minus 1 by root 11. The other possible questions in the position vector are the projection of A bar in the xy plane, the projection of A bar in the yz plane, and the projection of A bar in the xz plane. Let us see. The projection of A bar in xy plane is given by modulus of A bar xy is modulus of 2i cap plus bj cap, which is modulus of axi 3 j cap plus k cap modulus, and it is under root 3 square plus 1 square, that is under root 10. And in y z plane, it is 2I cap plus k cap, which is equal to 2 square plus 1 square under root, it is root 5. So this is about the different forms of question and position vector. And let us see the directions in a plane that is parallel to the ground. There are 4 directions here: east, west, south, north. This is the representation of horizontal plane in 4 directions. Suppose if any vector is along, a bar is along this direction, that is making an angle 45 degrees with the east and also 45 degrees with the north, we say this direction as northeast. And if the angle is other than 45, maybe less than 45 or more than 45, say for example 60 degree in the YZ direction, that is north and west direction. So this vector makes angle 60 degree with the north. And this direction is represented in 2 ways. One is 60 degree west of north, and or north 60 degree west. That is, the angle is between the 2 directions. The first direction is north, that is why we are putting north here, and the next direction is west. So it is 60 degree west of north. If you remove this off, we can represent it as north 60 degree west. These are the 2 ways. Suppose if it is 30 degree with west, then we say 30 degree north of west, like that. So these are the 2 forms of representation of directions in horizontal plane with respect to east, west, north and south. So let us take an example to represent all these things. For example, a particle moves 5 meters at an angle 37 degrees north of east along OA, and 3 meters towards east along AB, and 4 meters towards north along BC as shown in the diagram. So if you are asked to find the resultant displacement of the particle, then this is O along the path OA BC. The resultant displacement is the sum of 3 displacements. What is S1 bar is along OA, which is consisting of 2 components. With the east, it has a component cos, and with the north, it has a component sine. These are called rectangular components of S1 bar. That's why we take 5 cos 37 I cap and plus 5 7 37 and 37 degree J cap. That means we are taking east as x-axis, north as y-axis. That's why we are using the unit vectors I cap along east and j cap along north. That's why S1 bar is represented like this: 5 cos 37 degree I cap plus 5 7 37 degree j cap. And if the values of cos 37 is 4 by 5 and sin 37 is 3 by 5. That's why the vector form of S1 bar is 5 gets cancelled, 4i plus 3j, 4i plus 3j. And whereas at S2, there is only one direction, that is east. That's why we are putting 3i cap. S2 is nothing but 3i cap. And S3 is only one direction, that is north. And we are taking it as 4j cap. Now S bar is S1 bar plus S2 bar plus S3 bar. That is, you have to add the similar components. I cap in S1 and I cap in S2. That is 4 plus 3 I cap. And there is only other 2 components, that is J cap in S1 and J cap in S3, because in S2 there is no J component. That's why it is 3 plus 4 again multiplied with J cap. So the resultant displacement S bar is 7i plus 7j. This is the vector form. And its modulus is given by modulus of S bar is root over 7 square plus 7 square, which is 7 root 2 meter. The direction lies in the xy plane, that means northeast plane. So let us find the angle made by the resultant displacement with east. For that, we have to take tan theta, which is the ratio of the components along north and component along east, that is j by I. The components are 7 and 7, that means j by j, that is 7 by 7 is nothing but 1. When tan theta is 1, theta is 45 degree. So we can represent the direction of resultant displacement in the direction northeast, just like this. Because it is 45 degree, we have to represent the direction as the northeast. So ultimately, the resultant displacement is 7 root 2 beta along northeast. Thank you for watching my video.